Okay, let me share my screen so that we can. All right, all right. So, welcome once again. Welcome once again. This is Introduction to Blockchain Protocol Development. We've been doing um, a lot of, a lot of things when it comes to the blockchain space, but when it gets to the concept of blockchain protocol, it seems to we don't really have enough or sufficient understanding regarding it, and it's important for workshops like this to be put in place. It helps us come into an understanding of the importance of blockchain. So, in today's workshop, we're going to be looking at the basic introduction to blockchain protocol development. As we continue with this workshop, which we're truly hoping to see that something that will happen weekly. So, in today's workshop, we're going to be doing mostly on just the introduction part because there seems to be a lot of misconception when it comes to the idea and the concept of blockchain protocol development. All right, so this is actually what we're going to be covering in today's workshop. We're going to be looking at, okay, before that, let me just introduce myself quickly. So, Nanli Nathaniel, a blockchain engineer at Web3 Protocol Africa, powered by Guild Academy. So, what we do at Web3 Protocol Africa is blockchain protocol engineering. I will talk more in the community as we advance in the workshop. Yeah, like I said earlier on, we're going to be looking at introduction to blockchain protocol development. You can reach me at nanlinat, and this is our Twitter handle. So this is what I hope to cover with you in today's workshop. We're going to be looking at what exactly is protocol in Web3. Like I said earlier on, there seems to be a lot of misconception when it comes to what exactly is protocol. What exactly is protocol? There are many things that protocol when it comes to Web3. But regarding protocol development, protocol engineering, we're going to be seeing these things from its context. And one of the things I'll be telling us again is the role of protocol engineers. I want to believe that we have a mixture of people on the call. We have people who are developers already from maybe on a different protocol. Maybe let's say Cosmos. You may be a developer on Polkadot or any of them. But we're going to be looking at the rules of protocol engineers and where to start from. So these three things are going to be very, very broad when it comes to just the introduction of blockchain protocol development. And I hope that everyone who will follow this weekly workshop would, at the end of the day, be proficient when it comes to the idea of protocol development and a hands-on experience in some of the skills required to be identified as a protocol developer. All right, so what is protocol in Web3? So the first question I'm asking just to explain this concept is what is protocol? What is a protocol in Web3? Now, when it comes to the Web3, there are three ideas of protocol we have in the Web3 space. There are three ideas of protocol we have in the Web3 space. I believe we're following, right? If you're following, just a thumbs up, just so that I can know. And then we press further. I need to carry people along. Yeah, just a thumbs up, just so that I am aware that. All right. Yeah, can see hands up. All right. So there are three ideas of protocol we have in the Web3 space, and the first idea we have is the core protocol. The core protocol, and the second idea of protocol we have is layer twos, and the third is application layer protocols. I know while we're saying these things, they look very, very ambiguous, but believe me, they are not. As we advance, you discover that these things are not very ambiguous as they appear to be. So the first idea of protocol we have in the Web3 space is core protocol, and then we have layer twos, and the third is application layer protocol. Application layer protocol. All right, looking at the first core protocol, what exactly is it? Now, this core protocol is the fundamental layer that defines how a blockchain network operates. It defines how a blockchain network operates. So when you hear the word protocol, inside of that word you're hearing protocol, like I said earlier on, we have a concept of it in three places. The first I said is the core protocol, the second is L2s, and the third is the application layer protocols. So for core protocols, I'm explaining it as the fundamental layer that defines how a blockchain network operates. So any blockchain you're seeing today, what makes it possible to operate the way it operates is based on its protocol. So core protocol basically is the fundamental layer that defines how a blockchain network operates. And then the second point here, it includes rules for consensus, execution, networking, and state management. Essentially, the backbone that ensures the blockchain functions correctly. So you'll be wondering how we say that blockchains are decentralized, blockchains are scalable, there's security, all of these things you're hearing within the blockchain. So the part that makes these things possible is the protocol of the blockchain. And you bear me witness that there are many things called protocol out there. Many things. So we have things like Cosmos, we have Solana, we have Polkadot. You're hearing all kinds of names. So what makes each of these protocols you're hearing now unique in their way is because of their core design, is because of their core protocol, core architectures. Yeah. So the next idea of protocol we have in the Web3 space is layer twos. Now layer twos are solutions. Okay, layer two solutions are protocols built on top of a layer one blockchain like Ethereum to improve scalability, reduce transaction cost, and enhance efficiency while inheriting security of the base layer. And then I wrote here, we have layer two solutions because of the limitations in layer one. All right, so now we have another concept called the layer twos. Initially, I began with the core protocol, and some of the examples of those core protocols we have at the Ethereum. So we have L2s that are derivative from the L1s. Like I wrote here, they are solutions. L2 solutions are protocols built on top of an L1 blockchain like Ethereum to improve scalability. What that means is that we cannot have L2s if there are no limitations in the L1. So when it comes to protocol, we have a core protocol and we have L2s. L2s are as a result of the limitations that are found in L1s. So L1s we have are like the Ethereum, we have the Polkadot, we have yes. So all of these are L1s. So in that L1 there are limitations. For an example of that is the Ethereum. So we have many limitations in Ethereum, and some of the limitations is its ability to scale, and that's the reason why we have many L2s out there. So L2s are solutions to the L1 problem. But I want to understand this third part, which is very, very important. Now, that's where the misconception comes most often. Now, we have a concept of the protocol as application layer protocols. Now, these application layer protocols in blockchain are protocols built on top of core blockchain networks to provide specific functionalities like DeFi, gaming, and scaling. They rely on the security and infrastructure of core protocols, but define their own rules for interaction. I believe the next slide will explain more better. Now, let me explain the application protocol with the L1 concept. Now, remember I told you that one of the concept of protocol is its core layer, which is the L1. Now we are knowing that the L1, one of the example of L1 we have is the Ethereum. So we know that for L1, there are certain core components of L1s. And some of the core components of L1s are its ability to manage accounts, smart contract execution, block production, security, and all of these things. And now we are having another concept called the application layer. So what exactly is this application layers? We have other concepts in the Web3 space like Uniswap, Aave. You hear most developers calling Uniswap as a protocol. You hear many developers calling Aave as a protocol. So what is the difference between this protocol Uniswap, this protocol Aave, and blockchain protocol development? So when I say you're doing blockchain protocol development, what exactly do I mean? because we have many protocols out there. So how do we distinguish between the protocol development we're talking about and the protocols we have out there, like Uniswaps and Aave? So, like I said, these protocols like Uniswap and Aave, they are actually applications of the uniqueness that the L1, the core protocol, produces. So, like we wrote here, they define how users interact, swap tokens, lend us or slash borrow, and play games. So remember what's here. So we have the core protocols like L1 that manage accounts, smart contract execution, block production, and security. Now, these protocols like Uniswap and Aave, they implement the features you will find in core protocols. They implement the features found in core protocols. So the concept of Uniswap is something that you can find in every L2. The concept of Uniswap is something you will find in many decentralized applications. So these protocols that we have, they are implementations of the unique architecturings of the core protocol. All right. So we also have the application here as it leverages the security, consensus, and state storage of the base blockchain. So what this is telling us is, running back to the previous slide, and then I tie these things up for a better understanding. So remember what I told you now from the slide. I said we have core protocols, we have layer twos, and then we have application layer protocols. Application layer protocols. And the first thing I said here is that for core protocols, they are the L1s. They are the L1s, the backbone of the blockchain itself. What makes blockchain possible? What makes the blockchain possible are a component of the core protocols. And then we have the L2s. The L2s now are a derivative of are derived based on the limitations that are found in the core protocol. And now we also have the application layer protocols. Now the application layer protocols are the application, now the usage of the unique feature that is found in the core protocol. So every protocol, like Ethereum or Polkadot, they have a unique taste. There's something unique they are bringing to the whole idea of blockchain. So application layer protocols like Uniswap, they leverage on those uniqueness, and that's the reason why we have them. Core protocol, we have layer twos, and then we have application layer protocols. I believe that's clear. All right, so what we have seen so far are the basic concept of blockchain, but why are they important? Why are they important? What I just showed you right now, they are the basic concept of blockchain. But now I'm calling it basic concept of blockchain. It will be so terrible that you discover that many developers out there don't have an understanding of what these things are. I just showed you the difference between L1, L2, and application layer protocols, about core protocols, L2s, and the application layer protocols. So the question I'm asking now, before we press further, is why are these things important? Why do we need to have an understanding of core protocols, about layer twos, and the application layer protocols? Why are these things important? And then I quote here, success is neither magical nor mysterious. Success is natural consequences of consistent applying the basic fundamentals. All right, that's just me writing some code there. So if we truly want to see where the idea of blockchain, we'll only be doing so little if we don't start to contribute to a large extent from the protocol level. And that's the reason why this workshop is very significant. And one of the reasons why this thing is important for me to have an idea of this is blockchain protocol engineering is basically understanding how this basic works. When you know what or how the blockchain work, you're already a protocol engineer. When you have a clear understanding of how blockchain works under the hood, you are a blockchain engineer. So these things are not rocket science. It's just you being curious to understand how this thing works under the hood. And the future of this technology is at the mercy of nations producing protocol engineers, crack devs who can literally design and write a protocol from scratch. So we need to have an understanding of the core protocol. we need to have an understanding of L2s, and then we need to have an understanding of the application of all of the ideas that makes up the blockchain. It's just amazing. All right. So the rules of protocol engineers, the rules of blockchain protocol engineers. What are their rules? From their rules, you begin to understand some of the components of these things. All right. Knowing fully well that the core protocol consists of some important component of the blockchain, like the consensus client, the execution client, and all of these things. What exactly is the role of a blockchain protocol engineer? When somebody says, I'm a blockchain protocol engineer, what exactly is that person saying? What that person is saying is that he's a blockchain client developer, is a blockchain client developer. And when we talk about clients, we're talking about the GET client, the RED client, the Nethermind, the Prism, and the Lighthouse. So blockchain protocol engineering consists of understanding the different component of blockchain. You're not just building decentralized application. You're figuring out the reason why certain decentralized applications claim to say they are scalable on certain blockchains. You are understanding the architecturings of these things. Now, for Ethereum, there are two fundamental components of Ethereum, which is the REST client and the execution client and the consensus client. In the consensus client, we have the validators client. So all of these things are important. So if you claim to say you're a blockchain protocol engineering, what you're doing basically is that you're building the execution client and the consensus client. You're building these things. So what other role does blockchain engineers do? Now they also have the liberty to implement their own clients. They also have the liberty to implement their own clients. Have you not wondered why we have many clients out there? We have red client from on the execution table. We have the red client, we have the get client, we have Nethermind, we have clients, different clients. For the consensus clients, we have Lighthouse, we have Nimbus, we have clients out there. So have you not asked questions like why are these things there? Where are they coming from? Now the uniqueness of these things, they are built by the blockchain protocol engineers. The blockchain protocol engineers. Now they design and implement consensus mechanism. That's the proof of stake and proof of work and etc. So you are literally deciding how the blockchain operates. So we are not just focusing on decentralized application or running dApps and all of these things. You are involved in the how to of the blockchain. Yes. And they also develop and optimize zero knowledge proof, that the ZK proofs, threshold signatures and cryptographic primitives, bridges and interoperability. We have a wonderful protocol engineer in Africa, specifically Nigeria, who is a master in bridges and interoperability. A master of bridges and interoperability. So all of these things are the idea that makes up protocol, the core protocol of this. That's just it. When it comes to the execution client, the consensus client, the validators client, building these things, understanding how the execution client works, building these things with different languages. That's the idea of protocol. That's the idea of protocol. And unfortunately, we only have few Africans who are really looking into these things because they are not very, very clear and straightforward as they sound. We only want to do hackathons and just get money and run and go. And I'm not saying that hackathons are bad, but I'm saying if we truly want to contribute strongly in the blockchain, we need to start looking into protocol engineering. We need to start learning, finding ways to contribute to the consensus client, the execution client. I mean, right now I'm part of a team that trying to see how we will transition from beacon chain to beam chain. I mean, I'm just saying this, some people will be hearing me and like, what's this guy saying? What's this guy saying? The consensus client we know today, the operation of the consensus client is leveraging beacon chain. The consensus client is using beacon chain to attain its proof of stake. But right now, there are a group of guys who are trying to see how we will quickly transition from using beacon chain to beam chains. These things are sounding like what is this guy saying? Absolutely, that's how protocol sounds. But these things are not very ambiguous as they look. It's as simple as anything. It's just so that you have an understanding of how the clients work, the execution client, the consensus client, how this thing works. That's just what the blockchain protocol engineering is. All right. No, Sam, we need more protocol engineers. I'm supposed to even put Africa capital letter. We need more protocol engineers in Africa. The truth is this. Most of these guys that are presenting the blockchain to us, they don't really have practical issues to solve. We are the one we are the one facing terrible issues in Africa. So we need to find a way to design the architecture of the blockchain that will suit the problems we are facing in our everyday life. Believe me when I tell you this, that many times it's not that the decentralized application we are building are not effective enough, but you bear me witness that the average African is finding it difficult to relate with the decentralized application you are making. They are finding it difficult. The issue is not in a decentralized application. The issue is from the architecturing level. If we can find a way to make this thing more simple, to adopt more people, explain this concept to them, then I tell you this, Africa will adapt to the blockchain idea. But when we don't have more protocol engineers, how can these things be possible? How can these things be possible? Yeah. All right. So, seeing all of these things that we've said so far, where to start from? I mean, I've had a lot of conversation with some developers, and when I tell them about these things, the first question they will ask me is, how do we start? I mean, the information, they are random. I mean, for a blockchain developer, there are courses with very very well structured modules. You know that if you want to be a protocol, if you want to be a blockchain developer, there's a course that teaches you about front end. Okay, if you want to be a full stack when it comes to the blockchain development, the courses are well arranged. But when it comes to protocol development, protocol engineering, it seems as though these things are scarce. They are not. They are not scarce. It's just because the idea of protocol engineering is not well explained in detail. So it is still looking very ambiguous to us. So when somebody is trying to introduce you into protocol engineering, you just say, ah, no, this thing is not my own. But it is. It is. It is. It is. So where to start from? I have some highlights here on where to start from. The first thing to start is be curious. Like I said, this workshop is just a quick introduction. As we advance further, we're going to be becoming more technical as we advance. But the first thing I want you to understand is when it comes to being a protocol engineer, one of the flavor you should not miss out is being curious. Being curious. I mean, for you to be in this call is an indication that you are curious, and it's something we need to consciously applaud us for. So we need to be curious. And then the next thing is pick a chain and study its architecture, e.g. the Ethereum. And that's what we're going to be doing all through this workshop. We're going to be looking at the architecture of the Ethereum protocol. We're going to be looking at the execution client. We're going to be looking at the consensus client, and we're going to be looking at how we can contribute practically to a client. We're going to be seeing these things, how to apply for an issue and to apply to core protocol stuffs. We're going to learn a lot from this workshop, believe me. We're going to learn a lot from this workshop. And then the next thing to do is you need to learn a low level programming. You cannot do protocol with solidity. You cannot do protocol with solidity. Solidity is a high level language that we use to write smart contracts. Yes, for our decentralized application. But when it comes to core protocol engineering, you need a core protocol language. You need languages that suits to that taste. And some of the languages that you can adapt to is Rust, and I think one of the some of the clients that implement the uniqueness of Rust is the Red and the Lighthouse. There are many tools we use from a protocol level that were written with Rust, like the Foundry that many developers are using right now. It was written with Rust. It was written with Rust. And we have Polkadot, their substrates, also written with Rust. And then we have the Go language, the Golang. We have Get, the Get execution client, and we have the Prism. All of these clients were written implementations with the Go language. We have the C++. These clients, that's the best suit. They implemented their logic with the C++. So the next thing you need to do when it comes to becoming a protocol engineer after picking a study case like Ethereum is you need to begin to learn a low-level programming language like Rust, Golang or C++. And the next thing is hands-on experience in running a node. Now, all of these things we're saying, we're going to be having a workshop to explain these things. In this workshop, we're going to be having a moment where we look at Rust, we're going to be looking at Golang, we're going to be seeing these things so that I'm really looking at how this workshop is going to be very, very robust and fruitful to as many who want to venture into protocol engineering. So we'll look at all of these things and hands-on experience in running a node. Hands-on experience in running a node. Because in protocol engineering, you're going to be doing a lot of networking. You're going to be looking at P2P networks. You're going to be playing around with RPCs. So it's very important to understand how a normal node should work. You need to run a node to see how these things work, how transactions are added to the block. You're not just reading them in mastering Ethereum, you are seeing them. You're running a node. So when it comes to protocol engineering, you have a hands-on experience to how protocols work. You're not just reading them from books, you have an experience. And then the next thing you need to do is build and contribute to core protocols. We'll see how we'll work with these things as we advance in our workshop. And the next thing is you need to join a community. You need to join a community. You need to join a community. We have a community of core devs interested in protocol. That's how Web3 Protocol Africa came up. So what we do basically in Web3 Protocol Africa is we do all of these things we said. We are a group of people who are curious. Yes, we study architectures of different blockchain protocols, and we write low-level programmings like Rust, Go, and C++. We have hands-on experiences in running nodes, and we contribute to core protocols. Core protocols, yeah. So you need to join a Web3 protocol community, a Web3 protocol community. Yeah, that will help you a lot. And we also have the EPL, the Ethereum Protocol Fellowship. This is an official community for Ethereum that sees how they can adopt more protocol engineers. So it's a goal. We have a community. In our community, we share materials from the EPF that will help you a lot. Now, for the Ethereum Protocol Fellowship, they've released their form. So Ethereum Protocol Fellowship, they used to have a program that runs for 4 months. They they enroll new protocol engineers and they teach them these things we'll be learning here. The execution client, the consensus client, and different of these clients. And these devs will now learn how to contribute. Some devs go ahead to protocol engineers. Somebody will just sit and say, I want to write a consensus client with Rust. And then they write it with Lighthouse. And today we are using it. Somebody will sit down and say, I want to write the execution client with C++, and then they will write it and give it a name. Somebody will say, we want to write the execution plans with TypeScript. Somebody will say, we want to write it. Now, that's the reason, that's how we came about the diversity of clients we have today. These things are all experiments. So the Ethereum Protocol Fellowship, their core focus is to see how they can adopt more protocol engineers in that space. And their form is out. I will be sharing the link with us on our community, the Web3 Protocol Africa. If you're granted access to join, you'll be paid. I think, yes, they pay their students. I think the last time I checked, they paid 1,500. To those of you who are needing money, the way I do, you can join. You can join. You can apply, and if you're able to make it, you're learning. While you're learning, you are paid $1,500. The reason why I keep emphasizing this is because I know my audience. All right, so basically, that's just it. I don't know if you have any question for me regarding all that we've said. If there's any question, something that you're not clear of, please you can ask, and then I'll be delighted to go back and explain again. Is there any question?
Okay. Good day, everybody.
Yeah.
So you talked about the ETF, right? So I wanted to ask, so how's the application process like?
All right. That's a very nice question. Um, I'll be dropping in the to those of you who are yet to join the community. We place the links to our community on all of our social media platforms. You can do well to join the Discord and the Telegram. I'll be sharing the link to the EPF program so that you can join. But to the question Casey asked, how do you go about the EPF? All right. So how do you apply? That's your question, right?
Yeah,
All right. So on the form, you will see a very, very well detailed answer to your question. But from what I've seen from the EPF thus far is you're going to be doing a lot of research. You're going to explain a core protocol concept and you submit it. And you're going to present maybe a very, very well and well detailed ironed out contribution that is protocol related, an open source contribution that is protocol related. We're not saying you present a project that you contributed to a decentralized application. No, you contribute to a core protocol problem. Maybe let's say you contributed to Lighthouse. You can share that link to your contribution and they will do a review on that. And so basically, that's just it. It's not very very ambiguous as it sounds. The only thing they're expecting from you, I'm not an EPF member, but I'm also hoping to be part of them soon. The only thing they expect from you is um, um, they want you to show them that you can push with protocol engineering because like I said earlier on we have just few people who are looking into this, and the truth is this is not as easy as I'm making it sound. Protocol engineering will demand a lot from you. There are instances where you read, you study, you write, you're not understanding. So they make it such that they want to see your curiosity. How far can you go alone? And that's the reason why they are making their form that way. So show us what you have done so far, even without our help. Show us what you've done so far. Okay, we've seen that you were able to contribute to protocols, to execution or to consensus client, even without our support. So it means that if we help you, you can do more. Because the idea is that after the end of that program, the idea is that you can now begin to work with one of the clients. I mean, based on the last meeting we had in the EPF, announcement were made that it's going to be very, very rigid. How that many clients will be looking at the students that are in the EPF. Once you are showing them curiosity, they can apply. They can give you a to be a contributor, and that's a win-win for you. You're paid while you're learning, and when you're done learning, you have a guarantee of a job. It's just amazing. It's just amazing. So yeah, so that's it about EPF. Yeah. If you want to know more, please you can check them. You can check them. Let me see if I can drop a link regarding them. Yeah. So is there any other question? I hope that's clear, Casey.
yeah, it is.